Welcome dear learners. We are continuing Unit 2 Chemical Bonding and Molecular Structure. In the present module, we are discussing ionic bond. In this module, we will go through chemical bond, its definition and types of chemical bond, factors affecting ionic bond formation, characteristics of ionic compounds, Bond's theory of ionic lattice, Bond-Lande equation, and problems based on these concepts. First of all, we are discussing about chemical bond, its definition and different types. All of you are familiar with the concept of chemical bond. Suppose you are taking a compound that is simply our common salt, that is NaCl. There exists a force of attraction between sodium and chlorine. That bond is simply known as the ionic bond. But you are taking the water molecule. There exists some force of attraction between oxygen and hydrogen. That bond is designated as the covalent bond. Ionic bond and covalent bond are two most common type of bonds. However, whenever you are considering a metallic crystal like a piece of gold, a small piece of sodium, etc., there exists some other different type of force of attraction. That bond is termed as the metallic bond. In addition to these three bonds, there may be coordinate bond, hydrogen bond, etc. So, in this part of the discussion, we are focusing on different type of chemical bonds and its definition and various aspects. First of all, a chemical bond is defined as the force of attraction which binds atoms together in a molecule. Suppose we are considering a molecule of sulfuric acid. Its molecular formula is H2SO4. In order to connect hydrogen, sulfur and oxygen atom together to form H2SO4, there must be some force of attraction. That kind of force of attraction is defined as a chemical bond. The bonds are formed due to the tendency of atoms to achieve a stable electronic configuration, often resembling the nearest noble gas configuration. You know the fact that in the periodic table of elements, noble gases are associated with the stable electronic arrangement or electronic configuration. Now the question arises, why elements undergo chemical bond formation? The simple answer is like this: elements will undergo chemical bond formation in order to attain stability. That is, the bonds are formed due to the tendency of atoms to achieve stable electronic configuration, often resembling the nearest noble gas configuration. There are several type of chemical bonds, and we are now focusing various kind of chemical bonds. Different type of chemical bonds are: first one, ionic bond; another one is covalent bond; third one is metallic bond; fourth one is coordinate bond or dative bond; and another category is hydrogen bond. So, these are various type of common chemical bonds, out of which the first two, namely ionic and covalent, are more popular among different molecules. Now, let us have a glimpse on each of these type of chemical bonds. First of all, we are focusing on ionic bond. What is an ionic bond? This is the definition: a chemical bond formed by the complete transfer of electrons from one atom to another is called ionic bond. So, ionic bond formation is associated with the formation of ions. This is because during the formation of an ionic bond between two elements, there occur the complete transfer of electron from one element to another. Preferably, it is formed between a metal and a non-metal. Electron generally transferred from the metal atom to the non-metal atom. For example, our common NaCl, you are familiar with the fact that NaCl comprised of Na plus and Cl minus. We can enter into more details of ionic bond. This ionic bond creates, or during the formation of ionic bonds, there occur the formation of oppositely charged ions, and that ions will attract each other. The force of attraction between oppositely charged ions is known as Coulombic force of attraction or electrostatic force of attraction. An ionic compound is generated by the electrostatic force of attraction between positive and negative ions. Usually, the ionic bond formation occur between metals and non-metals. I just mentioned earlier that NaCl consists of sodium metal and chlorine non-metal. So, it is formed, the ionic bond in NaCl is between a metal and a non-metal. Ionic bonds arise between atoms with significant electronegativity difference. You consider the case of sodium chloride. Sodium metal is electropositive, so it is associated with the very minimum value of electronegativity. Chlorine is a non-metal which is having high electronegativity. So, on a sum, if you are taking NaCl, there is considerable electronegativity difference between the participating atoms. This is the formation of NaCl, which is illustrated by this picture. Here you can see a sodium atom with one electron in the outer shell, and that electron is transferred to the chlorine. Chlorine atom has 7 electrons in its outermost shell. During this transformation, sodium is converted to Na plus and Cl is converted to Cl minus. Both Na plus and Cl minus are oppositely charged ions and having stable electronic configuration. Now there occur some electrostatic force of attraction between Na plus and Cl minus, and this electrostatic or Coulombic force of attraction is known as ionic bond. Now we are discussing the second type of chemical bond, that is the covalent bond. A covalent bond is formed when the electron pairs are shared between atoms, or a covalent bond is formed as a result of electron pair sharing. These electron pairs are said to be shared pair or bonding pair. The stable balance of attractive and repulsive forces between atoms when they share electrons is known as covalent bonding. You consider the formation of H2 molecule from 2 hydrogen atoms. During the formation of H2, the electrons, there occur a sharing of electron pair between 2 hydrogen atoms. So, a covalent bond is formed by the mutual sharing of electrons. Based on the number of electron pairs shared, there are different types of covalent bonds. First of all, single bond. A single bond is formed by the sharing of one pair of electrons. Example, H2, Cl2, Br2, I2, etc. This is illustration of single bond in H2 molecule. You can see the sharing of a pair of electron between 2 hydrogen atoms. So, a single bond is formed by sharing of a pair, one pair of electrons. Now, how a double bond is created? You are familiar with the fact that a double bond exists between 2 oxygen atoms in O2 molecule. That is, the O2 molecule is formed by the sharing of 2 pairs of electrons between oxygen atoms. It is very well understood from this illustration. The first oxygen atom has 6 electrons in its outermost shell. Again, the second oxygen also having 6 electrons. As a result of the formation of a double bond between these 2 oxygen atoms, there occur stability because both oxygen will attain octet of configuration. So, in the formation of O2 molecule, there occur the sharing of two pairs of electrons, and hence the resultant bond is called a double bond. Now, consider the formation of a triple bond in nitrogen molecule. In the case of a triple bond formation, it is clear that there occur the sharing of three pair of electrons. A clear-cut example is the formation of nitrogen. In the nitrogen atom, there are 5 electrons in the valence shell. As a result of the sharing of three pairs of electrons to form endo molecule, there occur a triple bond formation, and as a result, each nitrogen atom attain stability by receiving their octet. Now, a covalent bond holds roughly 80 kilocalorie per moles of energy. You know the fact that bond formation is an energy releasing process, that is exothermic process, and bond breaking is an endothermic process. So, during covalent bond formation, there occur the nearby liberation of 80 kilocalorie per mole of energy. This is an approximate value. The atoms that are bonded have definite orientations relative to one another. This point is very, very important as far as the covalent bond formation is concerned. The covalent bonds have definite orientation with respect to the atoms present in the molecule. That means the covalent bonds are directional. You are familiar with the bend shape of water molecule, tetrahedral shape of CH4 molecule, pyramidal shape of ammonia molecule, all happened because of the fact that covalent bonds are directional. Now, we are considering the third type of chemical bond, that is the metallic bond. The collective sharing of a sea of valence electrons amongst many positively charged metal ions is referred as a metallic bond. Now, we can consider the case of a metallic crystal. For example, we are imagine a small piece of metallic gold. In that metal piece, according to the electron C model, there are so many gold ions, gold positive ions, and these gold positive ions are embedded in a sea of electrons. Electron C is produced by the ionization of the metal. So, the positive charge metal ions in language of metallic crystal is termed as metal kernels. So, in a metallic bond, there occurs some electrostatic force of attraction between positively charged metal kernel and negative charged electrons of the electron C. Such a kind of interaction is referred as the metallic bond. Metallic bonding is a sort of chemical bonding that is responsible for various features of the metal, including metallic luster, malleability, heat and electrical conductivity, ductility, and most of the properties associated with the metals. So, the force of attraction between positively charged metal ions or metal kernel with negative charge electrons belongs to electron C is known as the metallic bond. The strength of a metallic bond is influenced by several factors, and these factors include the total number of delocalized electrons, that is the total number of electrons present in the electron C. The second factor that governs the strength of the metallic bond is the magnitude of metal cation's positive charge. Third factor is cationic radius. So, on a sum, these three factors will govern the strength of a metallic bond. This is the pictorial illustration of a metallic bond. Here, the orange colored metal positive ions are distributed in a sea of electrons. Electrons present in the electron sea are designated as green colored balls. So, there occurs some electrostatic force between M plus and the electron, which is termed as the metallic bond. Now, another category of chemical bond. It is nothing but the coordinate bond or dative bond. Dative bond is the synonym of coordinate bond or coordinate covalent bond. The correct name is coordinate covalent bond. For convenience, you can call it as simply the coordinate bond or the dative bond. What about the dative bond? A bond where both shared electrons come from the same atom is known as the dative bond or coordinate bond. You know the fact that for the formation of a covalent bond, you must have two electrons between them at least. That is, there must be the sharing of at least a pair of electrons between two atoms for the formation of a covalent bond. Suppose if one atom has no electron to share with the other atom, in that circumstance, the second atom will donate both the electrons for the formation of the covalent bond. In that circumstance, the covalent bond formed is called coordinate covalent bond. That is, a coordinate covalent bond is a chemical bond in which both the electrons required for the formation of a covalent bond is donated by a single atom. The atom donate the electron is known as the donor and the next atom is called acceptor. So you can say that the coordinate bond or dative bond is a kind of donor-acceptor bond. NH4 plus formation clearly depicts the formation of coordinate covalent bond. Here you can see nitrogen atom of ammonia molecule has a lone pair of electron. However, H plus, that is the proton, has no electron in it. So, if there occur the formation of a bond between nitrogen atom of ammonia with H plus, that bond is nothing but the coordinate bond. So, for the formation of a covalent bond between nitrogen atom of ammonia and H plus, both the electrons are donated by the nitrogen. So, nitrogen donate its electron to H plus during the formation of NH4 plus. So, there occur a coordinate bond between nitrogen atom of ammonia and H plus, which results in the generation of NH4 plus ion. Hydrogen bond is another important category. Even though hydrogen bond does not belongs to the primary bond force of attraction, it is also highly significant. Hydrogen bond can have several influence in the physical properties of molecules, the force of attraction, in controlling the physical state, etc. Now we can define hydrogen bond. A hydrogen bond can be defined as the attractive force that binds one molecule's hydrogen atom with electronegative atoms like fluorine, oxygen, nitrogen, etc. of another or same molecule. So, this hydrogen bond is a force of attraction between hydrogen atom and an electronegative atom. Both the hydrogen and electronegative atom may be from same molecule or maybe belongs to two different molecules. So, if both hydrogen and electronegative atom belongs to two molecules, then it is called intermolecular hydrogen bonding. A simple example of a molecule with intermolecular hydrogen bonding is water molecule. In the water molecule, there exists some force of attraction between hydrogen atom of first water molecule with oxygen atom of the second water molecule. So, the force of attraction is between two molecules. Such force of attraction is termed as intermolecular hydrogen bonding. Now, if hydrogen and the electronegative atom belongs to the same molecule, then it is called intramolecular hydrogen bonding. You consider the case of the organic molecule salicylic acid, that is orthohydroxybenzoic acid. There is a COH group and OH group in ortho positions. So this is salicylic acid. On looking to this structure, you can see there exists some hydrogen bond between oxygen atom and the hydrogen atom. But both the oxygen and hydrogen belongs to same salicylic acid molecule. So this depicts the formation of intramolecular hydrogen bonding. So salicylic acid consists of intramolecular hydrogen bonding. Water consists of intermolecular hydrogen bonding. Now, the magnitude of hydrogen bonding depends on the physical state of the compound, which is maximum in solid state and minimum in gaseous state. So, in the solid state, the magnitude of the hydrogen bond is highest. In gaseous state, it is the least. This hydrogen bond allows to influence the structure and properties of compounds strongly. For a simple example, why water exists as a liquid at ordinary condition and H2S is a gas? In order to answer this question, we can consider the intermolecular hydrogen bonding in water. Water exists as a liquid due to the presence of intermolecular hydrogen bonding, whereas such hydrogen bonding is absent in H2S. So, under ordinary conditions, hydrogen sulfide exists as a gas and water exists as a liquid. We can drink water, we can use water for different purposes like bathing, washing, etc. etc. All these are possible due to the liquid state existence of water. Water molecule has a high boiling point. All this happen due to the presence of intermolecular hydrogen bonding in water. Now, factors affecting ionic bond formation. We are now exclusively discussing ionic bond and we are now focusing on various factors that affecting ionic bond formation. So, the most important factors are discussed here. Ionization energy, a lower ionization energy of the cation forming element facilitate removal of electron and enhance ionic bond formation. For example, alkali metals are associated with low ionization enthalpy or ionization energy. They can readily form cations. The second factor is electron affinity. A higher electron affinity of anion forming element promotes the ionic bond formation by releasing energy when electron is accepted. For example, halogens have high electron affinity, making them strong candidate for formation of anions and hence ionic bond. Another factor is lattice energy. Higher the lattice energy or higher lattice energy of the ionic crystal generates extra stability, or this implies that higher lattice energy stabilizes the compound by compensating the energy required for the formation of ions. Or a crystal with high lattice energy can form various kind of ionic bonds. Lattice energy is greater for ions with higher charge and smaller ionic radii. For example, magnesium oxide has higher lattice energy than NaCl. So, lattice energy is a crucial factor that affect ionic bond formation. Another factor that govern ionic bond formation is the electronegativity difference. A significant electronegativity difference favors ionic bond formation by promoting complete transfer of electrons. For example, in NaCl, the electronegativity difference between two atoms, that is sodium and chlorine, is 2.1, which favors ionic bond formation. Charge on ions. Higher the charge on the ions result in stronger electrostatic attraction, increasing the strength of ionic bond. For instance, Mg2 plus and oxygen 2 minus form stronger ionic bond than Na plus and Cl minus because of the high charge on magnesium and oxygen compared with the ionic compounds. The main characteristics are they are associated with high melting and boiling points. Ionic compounds have a strong electrostatic force of attraction between oppositely charged ions, requiring significant energy to break. For example, NaCl melts at 801 degrees Celsius and boils at 1413 degrees Celsius. They are hard and brittle. The strong ionic bond make ionic compounds hard, but they are brittle due to rigid arrangement of ions in the lattice. A shift in layer causes like charges to ripple, leading to cleavage. Solubility in water is another characteristic feature. Most of ionic compounds are soluble in polar solvents like water. Water molecule stabilizes the ions through solvation or hydration energy. Electrical conductivity. In solid state, ionic compounds do not conduct electricity because ions are fixed in the lattice. However, in molten or dissolved state, they conduct electricity as the ions become free to move. Another characteristic feature is crystalline structure. Ionic compounds form well-defined crystalline lattice due to orderly arrangement of ions present in it. These structures vary depending on size and charge of ions. This is the crystal structure of NaCl. This structure is otherwise called the rock salt structure. Now we are discussing Bond theory of ionic lattice. Bond theory of ionic lattice explains the stability and energy associated with the formation of ionic crystals. It primarily focuses on the balance between the attractive and repulsive force in an ionic lattice. When oppositely charged ions are arranged themselves in a crystal lattice, strong electrostatic force hold them together. The total energy of the system, that is the lattice energy, depends on the interaction between ions. Attractive forces are there, and the attractive forces are due to electrostatic or Coulombic interaction between oppositely charged ions. The attractive potential is proportional to minus 1 by r, where r is the distance between the ions. There occurs some repulsive force also. These arise from the overlap of electron clouds when ions are brought very close together. The repulsive potential is often modeled as proportional to 1 by r raised to n, where n is a constant called Bond exponent, which depends on the nature of the ions. Lattice energy U is another important factor which is associated with the Bond theory. Lattice energy is the energy released when 1 mole of an ionic lattice compound is formed from its gaseous ions. It depends on the balance between attractive and repulsive forces. Now we are discussing the Bond-Lande equation. The Bond-Lande equation is a mathematical expression used to calculate the lattice energy of an ionic crystal. It incorporates the balance between attractive electrostatic forces and repulsive forces in an ionic crystal. The Bond-Lande equation is shown here. U is equal to Na into m z plus z minus e square divided by 4 pi epsilon 0 r0 into 1 minus 1 by n with a minus sign. So, the various factors in this expression are here. Na is the Avogadro number, m represents the Madelung constant, depends on the geometry of the crystal lattice, Z plus and Z minus are the charge of the cations and anion, Small e represents elementary charge of the electron. Epsilon 0 is the permittivity of the free space. R0 is the equilibrium distance between cation and anion, or it is otherwise termed as the ionic bond length, and N represents the bond exponent. Now, Maitland constant is reflect the effect of lattice geometry on electrostatic interaction varying with the crystal structure. And you know this equation is called the Bond-Lande equation. Here there is a constant, that is Maitland constant. Bond exponent is also present in this expression. The bond exponent account for ion specific repulsion based on their electron cloud properties. There are so many limitations for Bond-Lande equation. It assumes perfect ionic behavior, neglecting covalent or polarization effects in bonds. Repulsive force are simplified using bond exponent, which may not accurately model all systems. It does not consider thermal vibrations or imperfections in the lattice. Now we are discussing some problems based on the concept we have discussed so far. This is the first multiple choice question. Which of the following factors decreases the likelihood of ionic bond formation? These are your options: high lattice energy, large electronegativity difference, high ionization energy of the cation forming atom, small size of the ions. This is your answer, option C, high ionization energy of the cation forming atom. This is the second multiple choice question. Which of the following is true about ionic compounds in the molten state? These are the options. They are good conductors of electricity. They are insoluble in water. They do not conduct electricity. They are volatile liquids. Your answer is option A. They are good conductors of electricity. You know the fact that in the molten state or in the liquid state, the ions in the ionic crystal are free to move and they can act as very good conductors of electricity. This is the third one. According to Bond's theory, what causes repulsive forces in an ionic lattice? These are the options: interaction between opposite charges, overlap of electron clouds, weak electrostatic forces, high ionization energy. Your answer is option B, overlap of electron clouds. Now, the lattice energy of an ionic compound decreases with, these are the options: increase in ionic charge, increase in equilibrium distance R0, decrease in Maitland constant, decrease in bond exponent. Your option is option B, that is increase in equilibrium distance R0. Now, what is the Maitland constant in Bond's theory? The options are a factor accounting for repulsion between ions, a value representing the arrangement of ions in a lattice, the ratio of attractive and repulsive forces, the distance between two ions in a lattice. Your answer is option B, a value representing the arrangement of ions in a lattice. That all about the present discussion, and have a nice learning experience. Thank you.